Hey everyone, it's Pryia. I know you guys probably miss Amy, but she'll be back in 2 weeks. She's off doing some stuff that's a little important right now, and you've got to be with me for the next 2 weeks. So if you're sad, I apologize, and if you're happy, well, welcome to the math session. All right, today I am your guest star, Pryia, so let's go ahead and just get started. I'm not going to waste your time because I like to answer questions, right? So here we go. Question 1. What is the measure of angle beta? Well, I don't know. I don't know what the angle is. We have to figure that out. And when we look at this problem, the first thing that should come to mind is SOHCAHTOA. I hope that's ringing a bell for some people. If not, let's talk about it really quick. Oh yeah, I promised I was going to be better at telling you what type of math we're doing. So today, this question is trigonometry. We can find it in middle, high school, and even college math, right? So trig is one of those things that are widely used. But let's get back to SOHCAHTOA. So we have the sine of the opposite over the hypotenuse, the cosine of the adjacent over the hypotenuse, and the tangent of the opposite over the adjacent. And all of this has to do with these lovely triangles that we see off to the side. So I gave us another slide just in case we need some extra space, but let's work our way through the problem. So we're looking for beta over here. And to solve for beta, we need a little bit more than just this 46, which happens to be the adjacent to beta. So we either need to figure out the hypotenuse or the opposite side, but we're not going to be able to do that without figuring out information from that smaller triangle. So let's look at the small triangle. We know that the small triangle is this size right here. I did not put it in the picture, but let's go ahead and state that they are 90-degree angles there. So we have two lovely right triangles. So let's look at that 51 degree. All right, we have 51 degrees here. And, we need to figure out that side that's attached to that larger triangle. So we need to figure out what's going on with ABE and not just worry about the large triangle BCD. So if we had to use what I already wrote, we would use that 40, which is the hypotenuse, and we need to figure out what that length is of that leg, which is the adjacent. So the opposite would be the yellow arrow that I drew here. So we're not worried about the opposite, we're worried about the adjacent and the hypotenuse. So going off of that, we will use cosine. Cosine of 51 is equal to the adjacent, which is 40. I apologize, it is not 40. The adjacent, which we do not know, all over 40, which is the hypotenuse. Okay, let's go ahead and solve. We need to get x by itself, so we multiply 40 on both sides. So now we put that into our calculator, and our calculator tells us that our x is equal to 25.17. That's great, because now we know a little bit more about what we need. All right, well, we know that this part is 25.17, but what is the whole line? Because we need the whole line, the whole leg, in order to answer that triangle. So we have 25.17, and we need to add 6 meters to that. When we add our 6 meters, we get a lovely 31.17. Okay, so now we know that this whole leg right here, so going to keep drawing on top of everything, is 31.17. Now that is what we need to solve for our beta. We have our adjacent, which we know is 46, and now we have the opposite, which is 31.17. All right, let's go ahead. We need adjacent and opposite, so that's going to be tangent. So we're going to have the tangent of beta that's equal to the opposite, which is 31.17, all over 46. Okay, we are almost there. Let's solve for the tangent. I meant just for beta. I apologize. We're solving just for beta, so we're going to take the inverse tangent. So beta is equal to tangent to the -1 And I'm going to just leave it in fraction form because our calculator will do the work for us, right? I don't want to change it into a decimal until now. When you type that lovely number into your calculator, you get that beta is equal to 34.12 degrees. Winner, winner, chicken dinner. Answer D. All right, I hope I didn't go too fast on that. I tried to take it as slow as possible without getting too excited about the math problem. All right, question 2. It's just to simplify. And all this stuff right here is going to be algebra, middle and high school, okay? You could see this also in college. This is kind of like your college algebra, right? This is algebra at all aspects of it. So it could be a little bit beyond high school. You could see it in college. So what is the first thing I always preach? Write PEMDAS, parentheses, exponents, multiplication or division, addition or subtraction. Oops, I didn't realize I was writing off the page. Let me try that one more time. Okay, so we have parentheses, exponents, multiplication or division, addition or subtraction. All right, that's there. So what's going to happen? We're going to start with our parentheses. So here is our set of parentheses. There is nothing to do inside of it. We're moving on. We have now our exponents. So our exponent is right there. We're actually going to work on that. So what do we need to do? We need to expand what's inside those parentheses, right? Because when we have something that's squared, it says what we see times itself. So we have to multiply it twice. So we're going to get x minus 3, x minus 3. That is how we take care of that exponent. We don't take it and just put it inside. That's illegal, right? We want to make sure that we're legal. So let's go ahead and do this function. X times x is going to give us x squared. X times negative 3 is going to give us negative 3x. Then we do negative 3 times x, give us negative 3x. And then we have negative 3 times negative 3 to give us positive 9. We're going to combine our like terms and then bring everything else down. So x squared minus 6x plus 9. Now bring everything else down. The 6, the positive, the 2, the division, and the 4. All right, well, we're finished with our exponent. So now we're going to work from the left to the right, and what we see we're going to do. Are we going to multiply or divide first? Well, here we have division first, so we're going to do it. 4 divided by 2 is going to give us 2. Bring everything else down. Okay, I'm going to take that 6 and multiply it into everything inside the parentheses. And I'm going to get 2 plus all that stuff. 6 times x squared is going to give us 6x squared. 6 times negative 6 is going to give me a negative 36, keep the x. And 6 times 9 is going to give me a positive 54. Right, now I'm going to combine like terms one last time. And I'm going to get 6x squared minus 36x plus 56. I don't have an answer choice to give you to tell you that it's A, B, C, or D, but winner, winner, chicken dinner. That is our answer. All right, now let's move on to some geometry. This geometry we will see in middle or high school mainly, right? And let's read what the question says. It says, in the figure AB, AB is parallel to CD, okay? So we know that this line is parallel to this line. And then they tell us that the triangle DEF is equilateral. And they want us to find the angle over here, which is Y. Well, they didn't really give us much to go off of, right? Parallel lines helps us with a lot. Well, parallel lines, when they have lines going through them, they're called transversals. So we can use that to our advantage here. We also know that DEF is an equilateral triangle. Well, we've got to work out with some type of angles. We have no angle to use. So let's start with DEF. We know that's an equilateral triangle. So what do we know about equilateral triangles and their angles? You should be saying that each angle is going to equal 60 degrees. But how do I know that? I know that the sum of all angles in a triangle will equal 180 degrees. So the sum of triangles' angles are 180 degrees. So if an equilateral triangle is there, we divide it evenly with the 3 angles that there are, and we get how many each angle will be. So when we divide 180 by 3, we get that each angle will now be 60 degrees. Okay? Now what? We've got our triangle, we've got some angles now to work with. What now can we use? Remember I said we could use those transversals to our advantage? We still can. So here's 60 degrees. I know that based on alternate exterior angles, that 60 degrees, if I alternate it on the line, means I will come over here, and it has to be on the outside, that's what exterior means, of the parallel lines, that will also be the same. So that will be 60 degrees. All right, we're getting somewhere. We're still not where we need to be, but we're getting somewhere. So we keep moving. If we now look at the triangle at the top, we have some more information. We know that the sum of that triangle is supposed to be 180 degrees. But what makes up those angles right now? We have a 60 degree, we have an x, and we have an x plus 20 degrees. Well, I don't know what else to do other than to help me solve for the x's and then work on the other transversal, that other side of the line. So let's keep working forward. 180 degrees is equal to 60 plus 20, which gives us 80 degrees, and x plus x to give us 2x. Okay. Now what? We're still solving for x. So we subtract 80 degrees on both sides, and we'll get 100 degrees is equal to 2x. Okay, almost there. Last step, divide both sides by 2. X is equal to 50. So the angle up here is 50 degrees, and the angle here is 50 plus 20, which is equal to 70 degrees. Okay, well, what do those angles look like comparing it down here? Y and this angle are alternate exterior angles. So if this angle is equal to 70 degrees, then the lovely y is also equal to 70 degrees. All right, so it's using as much as you can based from outside knowledge and the little bit that they give you in order to work your way through this problem. Oh, winner, winner, chicken dinner. Answer is B, 70. I almost forgot my phrase. Sorry, guys. All right, I didn't give you any answer choices on this one, but that's okay. You guys are smart enough to figure this one out. So let's work our way through. It says to find the derivative of the function. So this is definitely a calculus problem. We have derive in here, right? A lot of you go, ooh, calculus. It's not that bad, I promise. So here we have our calculus problem. We have to figure out how to do the derivative of the function. Well, by looking at the function, it's not just a one part. There are some rules that will have to come into play. The function that we are given, we're going to use the rule called the product rule. What do I know about the product rule? I know that if I know the rule, I can solve the problem. So, in order to do the product rule, we will need to do this. We will need to take f of x by itself and then the derivative of g of x. Then we'll take g of x by itself and the derivative of f of x. And that will give us what we're looking for, right? So let's go ahead and figure it out. So when we look at the problem gives us f of x, but then it gives us these two pieces. Well, how do I get a g of x from that? I label my first part my f of x, and I label my second part my g of x. The f of x that I'm using to label my first part, yes, is a part of the f of x function from the original problem, but we're not taking it as a whole. We have to split it up into f of x and g of x in order to solve by using the product rule. So before I even plug anything in, I'm going to take the derivative first, and then I'm going to plug everything in. For me, it's easier to do that. For you, it may not be, and that's okay. So if you don't want to take the derivative first, you can go ahead and plug everything in and take the derivative as you're working through the product rule that I wrote at the top. Or you can do it the way that I'm about to do it. So here we go. I'm going to take the derivative of f of x. So I have my f of x is equal to x squared minus 5. My derivative, my f prime of x, is now going to be equal to 2x. Take my 2 to the front and I lessen the power by 1, so I still have 1x left. Now my g of x is equal to x cubed minus 2x plus 3. So my g prime, which is the derivative of g, is going to be equal to 3x squared minus 2. Take the 3 to the front, lessen your exponent, right? And for the negative 2x, you take the 1 to the front, so negative 2 times 1 is negative 2, and you lessen your exponent, so you go from 1 to 0. So we have no x's left. So I'm going to now use this to plug into my formula that I wrote at the top, my product rule. So I'm going to start with my f of x. And my f of x is x squared minus 5. And I'm going to multiply that by the derivative of g of x, which is 3x squared minus 2. And I'm going to add that to the original g of x, which is x cubed minus 2x plus 3. And I'm going to multiply that by my derivative of f of x. Oops, I should have used green, which is 2x. Okay, we are closer to where we need to be. We're almost there. Now we just have to solve and figure it all out. So there's a lot of multiplying that's about to happen. So here we go. X squared times 3x squared, we get 3x to the 4th. Then we have x squared times negative 2, negative 2x squared. Then we go negative 5 times 3x squared to have negative 15x squared. And negative 5 times negative 2 is positive 10. All right, keep going. Don't forget your addition sign. 2x times x cubed is 2x to the 4th. 2x times negative 2x is negative 4x squared. And 2x times 3 is positive 6x. Okay, we're almost there. Now we combine all like terms. So I have a fourth here and a fourth here. And that's all the fourths I have. So 3 plus 2 is 5, x to the fourth. Now I have a squared here, a squared here, and a squared here. So negative 2 minus 15 is negative 17. Minus 4 more will take us to negative 21. X to the, oops, not to the fourth, to the second. Okay, I have an x by itself, so I'll add my 6x, and I do have a number that stands alone, plus 10. Winner, winner, chicken dinner, our answer is 5x to the fourth minus 21x squared plus 6x plus 10. Whew. We don't have to be scared of calculus, I promise. Right, here is a question about my class, so let's read it. It's statistics, almost forgot. Middle and high school math. So Miss Persaud's class was asked the amount of books they read over the summer. About half of the class had not read any books. About 30% read one book, and the remaining read 2 books. Which of the following is correct? So they didn't really give us anything at all to go off of. But let's figure out what we know. We know that about half the class hadn't read anything. About 30% read 1, and the remaining read 2. And when I look at my answer choices to give me some help, I notice I see mean, range, mean, median, median, mode, median, mode. Okay, so this has got to do with some type of mean, median, mode, or range. So I have to get numbers in order to be able to use this information. I can't just figure it out without some concrete data. So we go back to our question and we go, did they give us any amount of students anywhere? Nope, they did not. Did they give us a specific number of students when they gave us the pieces? No, they said about half, about 30%, and the remaining. So we don't have anything to go off of. So the thing about that is we now have to create our own data. To create our own data, we need to pick a number. Well, I'm not going to pick a really large number. Because if I pick a large number, then I'm going to be sitting here most of my tests going through this problem. So I've got to pick a number that's small enough to get me through the question, to help me understand what I need, but large enough to still give me some proper values based on the question itself. So you might be thinking like 15 or 20, that's still too much. I always consider my fingers a good amount. I've got 10 fingers, 10 toes, hasn't failed me yet. So let's just say that the class is 10 students. But remember, we made up the number. So moving forward, things are a little bit different. So I'm going to just make 10 student slots at the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to move that information. So then, oh no, it took everything with it. Okay, I'm not moving the information. I will just write in a different color. Let me do this. Let me put it at the bottom so we have some more space. And you know what? I can write my math problems anywhere I need to. All right, so let's start with the first part. It said about half of the class had not read any books. So what is about half? Well, it's as close to half as we're going to get, right? We don't know if it's less than half, how much less than half. how much more than half, so we're going to go with just half. So if we have about half of the class, well, I know half of 10 is 5. So I know that 5 students had not read any books. 1, 2, 3, 4, 5. So those are my 5 students, about 5, right, that hadn't read any books. So now I'm looking at my about 30. Well, it's about 30, so let's just say 30% for the sake of it. 30% of what? It's not 30% of 10. We don't know that we have 10 students in our class. So we're doing 30% of the remaining amount of students. So 30% multiplied by 1, 2, 3, 4, 5 students. Well, remember, we're not taking 30% as the percent. We have to take it as a decimal. Change 30% to a decimal, which is 0.3. Multiply it by 5. What do you get? 1.5. Okay, so we don't have a whole student to say that it's 2. We have close to 2. So at this point, we use our discretion. We're going to either use 1 or 2. I'm going to just use 1 student. And that's my 30%. And that 1 student read 1 book. And the rest of the people read 2 books. So I'm going to give them all 2. So based on this information, now we can use our answer choices to find out what we need. So I need to solve for my mean, my median, my mode, and my range. I'm going to start with the easy stuff first. Okay, so I'm going to do my range. My range is going to be 2 minus 0, which so happens to be 2. It's the largest number subtracted from the smallest number. My mode is the number that I see the most. Well, I see 0 the most. My median is the number in the middle, which happens to be 0 and 1. So when you have 2 numbers, you add them together and you divide by 2. We'll get 1.5. Just kidding. It's just 0.5 or half. That's what I was trying to say. And then we have the mean. You add everything up and divide by how many numbers you have. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 1 is 9. 9 divided by 10 happens to be 0.9. All right, well, now that I have my numbers to go with what I have, let's work through the answer choices. The mean is equal to the range. Well, the mean is 0.9 and the range is 2. The mean and median are equal. Well, the mean is 0.9 and the median is 0.5. The median is greater than the mode. Well, that's 0.5, which is greater than 0, so maybe. The median and the mode are equal. Well, the median is 0.5 and the mode is 0. So winner, winner, chicken dinner. C. The median is greater than the mode. See? Word problems aren't that bad. They didn't do anything to you, so let's not discriminate against them. Here's question number 6. It's probability statistics, right? So this is a middle school, high school problem all over again. Yeah, I like the higher level maths. So Sue is doing a card trick for her friends. Okay, this is fun information, but nothing useful. What is the probability of drawing a diamond or a king from the deck? So we need to know some pieces of information in order to be successful in this problem. First off, how many cards are in a deck? Well, I know from knowledge that there are 52 cards in a deck. The only reason I remember this is because my cousin used to say, do you want to play 52 pickup? throw the cards on the floor and that's it. You got to pick up all 52 cards, right? So we know 52 cards are in a deck. What else do we know? We know that there are 4 suits in the card deck. There are the hearts, the diamonds, the clubs, and the spades. All right, so I'm going to put 4 suits. Well, from the suits, we want a diamond. So let's start there. How many diamond cards are there in the deck? I don't know. We got to figure it out. So if I know that there are 52 cards in the deck, so 52 total cards, and I know that there are 4 suits, if I take 52 and divide it by 4, I'll get how many cards are in each suit. So there are 13 cards for each suit. Okay, what else do I need? I also need to figure out the kings in the deck. Well, how many kings are there? There's a king for each suit, right? So there's got to be 4 kings total. Well, we want to know the probability of a diamond, which we have here, and a king. But don't forget, you already pulled the king for the diamonds. So we have 1 less diamond that we're taking from the deck. So instead of 13 and 4, we have 13 and 3. So these 2 numbers are very important to us. We have 13 and we have 3. So what do I need to do? I need to make a fraction. How do I know that? I looked at my answer choices. All of my answer choices are in fractions, so I'm going to make a fraction and I'm going to figure this out. So what do I know about fractions? I know that no matter how I look at it, I'm going to have the part that I'm looking for over the total. So what are the part or the pieces that we're looking for? We're looking for the diamond or the king. Well, we have to add them together because it's the chances of one or the other. So we have 13 cards plus the 3 cards all over what? Our total is still 52. Nothing has changed there. When I add them together, I get 16 over 52. Okay, but how is that not one of the answer choices? Something's got to be wrong. So I have to figure out what to do. Well, it has to be reducible. So there's one of 2 options here. We can start reducing the 16 over 52, or what you can do is you can take 16 over 52, turn it into a decimal in your calculator, and then turn each of your answer choices also into a decimal. That will give you a decimal that has to be exactly the same, okay? So if you take 16 over 52 and turn it into a decimal, one of your answer choices will also be the exact same decimal. I just so happen to know that 16 over 52 is divisible by 4. I know that 16 is divisible by 4. I didn't off the bat know that 52 was divisible by 4, but it was worth the try. So when you divide the top and the bottom both by 4, you actually get 4 over 13, which, winner, winner, chicken dinner, gives us our answer of A. Right? So it doesn't seem too bad when I break it down. Hopefully I'm making it easier instead of more difficult. Remember, we couldn't take all 4 kings because we already took out all of the diamonds. So because a king is in the diamond suit, we have 1 less king overall to take out of the deck. So that makes 1 less chance of a probability. That's why we had to subtract the 1 diamond king that we already had. Okay, question number 7. It says that a triangle is formed inside of a square where E and F are midpoints and midpoints of AB and BC. If a dart is thrown, what is the probability the dart will land inside of the triangle? Probability means that this is a probability problem. It's a little bit more than just probability though, because now we need a whole bunch of outside information to help us solve for this problem. I'm staring at the problem and I'm going, well, what am I supposed to do? I don't have anything to work with. All I have is a square and a triangle. What do I do? Well, we go back to the problem and try to figure out what they told us. They did tell us that E and F are midpoints of AB and BC. Well, what does that mean? It means that E and F are exactly in the middle, the midpoint of those sides. So whatever the whole side length is, this part will be half and this part will be half to make up the whole, right? Same thing on the other side. So that's what they're telling us, but we don't have any numbers to work with. Here we go again. We've got to pick a number that makes sense, that will give us some nice halves, right? Well, I'm going to choose 10. I told you it worked before. Let's try it again. So if I make each side 10, I'll have a side of 10 here, a side of 10 here. Well, now I'm going to break up my midpoints into two pieces because they're broken up for me. So I'm going to have 5 here, 5 here, 5 here, and 5 here. I still have 10, 10, and 10. I know that it's a square. All of my sides are going to be equal, right? And now I know about these midpoints. Well, I need to figure out what my probability is to throw a dart and it potentially land in that triangle. So let's highlight our triangle so we have an idea of where we're going. So this is the part that we want to throw that dart in. Well, there is no way that I'm going to sit here and be able to actually give you this side over here. It's going to take a little bit more than just some regular geometry and knowledge to get us there. So we're not going to worry about that. We're going to worry about some other stuff instead. Instead, we're going to look at the problem in a different way. If I can figure out all of the non-shaded section, which is outside of the triangle, then I can figure out the triangle stuff, right? So we got to work our way that way. Well, I'm staring at this and I'm going, okay, well, this looks like a lovely triangle. I know that the corner of every square is going to give me a perfect 90-degree. And this is also the same triangle as the other one that I just drew. So I've got two of the same triangles. So if I find the area of one, I'm finding the area of both. So I'm going to name this number 1 and name this guy number 2. Let's work on them first. So the area of any triangle is going to be half times base times height. Apologize. So my base in this case is 10. It doesn't matter which triangle you're looking at. So I have A is equal to half times 10 times 5, which is my height. Excuse me. All right, let's go ahead and solve for this. Well, I'm doing my half after. 5 times 10 is going to give me 50. And then half of 50 is 25. Okay, that's giving me some information to work with. So remember, it's 25 each, not 25 shared. So I now know that the area of this and the area of that is 25. I'm going to box it so we know that it is the area. Okay, well, I still have another triangle over there that I need to figure out. Let's make him blue. He's already blue. Well, I can stare at this triangle and you're probably thinking it's an equilateral triangle. Not to pop your bubble, but it's not. I don't know that it is or it isn't. I don't know anything about this triangle other than a 90-degree angle goes here. So if we look at this another way, This triangle now turns this way to give me 5 and 5. That's something I know how to work with, right? So sometimes it's not just looking at the triangle the way that you see it, but working out in different areas, working it out different ways. So let's go ahead and solve for the area now of that lovely blue triangle. So the area is still the same, half. I apologize, my halves are coming out funky, times the base times the height. All right, not a problem. Plug in what you know. The area is equal to half times 5 times 5. Like I said, I'll do my half after. Let me multiply my large numbers. Area is equal to 5 times 25. All right, not bad. What's half of 25? My area here is equal to 12.5. Okay, so I'm going to put 12.5 over here, and I'm going to box it, because that's my area over there. Well, I've got all the areas outside of the triangle. What's stopping me from finding the area inside the triangle? Absolutely nothing. We have all the information we need. We just have to solve for a little bit more, and we're right where we need to be. All right, so if I have the outside space, I need to know the all space. I need to know how large this square actually is. How much area is it taking up? So I'm going to do the area of a square. Use a different color. I'm going to do the area of a square, which is length times width. And what do I have there? I have 10 times 10, which happens to be 100. Okay, this is the total area. Well, if that's all the area, and I need the area for the yellow part, which I haven't figured out, I can add some stuff together and subtract some stuff and figure out where I need to be. So what are we going to do? Let's add all the areas that we know together. 25 plus 25 plus 12.5. When we add those together, we get a lovely number of 62.5. Okay, that is the area of all of those non-shaded sections. Well, we need the area of the shaded section. Almost there. If all of the area is 100, we subtract what we know of 62.5, and we'll get the area of the part that we're looking for, which just so happens to be 37.5. Okay, so this is the area of the shaded section, which is the triangle. Okay, we're almost there. I see decimals. I know that to get to a decimal, I can start with a fraction. So to start with fraction, I'm going to need to figure out my top and my bottom, my numerator and denominator, which is my part over my total, my whole. So here we go. My part is going to be 37.5. What is my whole? What is my total? My total is 100. Remember, it's 37.5 is the shaded section over all of the entire square. When you do that, you get a lovely number of 0.375, which happens to be A, which is our winner, winner, chicken dinner. If you chose a different number, you would get a different number for your sides and your midpoints, but the percentage of the problem will still remain within the same. Okay, question 8. We've got 8, 9, and 10. We're almost there. Promise I'd be better at this, so we have another calculus problem. I know I can hear the oohs out there. So we need to find the domain of this. F minus g of x. Considering the following problems that they gave us. F of x is x minus 4, and g of x is x squared. So what are we doing? We are finding the domain. So to find the domain, we need to know what that is. Well, domain is always associated with the range. So generally when you hear domain, you hear range, right? So we'll just talk about both really quick. The domain is going to be your x-axis values and your range is going to be your y-axis values. We do not need the range in this case, we just need domain. So we need to figure out what the domain is for the functions when it's f minus g of x. So let's start figuring out what f minus g of x will look like. So f is x minus 4 minus g of x is x squared. Now you just put them together and figure out what happens. So now we have f minus g of x is x squared. I apologize. It is negative x squared. Negative x squared plus x minus 4. That is what f minus g of x looks like. Okay, well, now I need to find the domain of that. What do I know looking at this? I know that this is a quadratic. I know that quadratics give me parabolas. I know that parabolas look like what I'm about to draw. So I have a negative in front of my x squared, which is not a good thing. Negatives are sad, right? So I'm going to make a sad looking parabola. Right? And remember, we're looking at the domain of something. So we're looking at how far to the left and the right that our parabola is going to extend to. Well, as our parabola continues, it will go off to negative infinity and to infinity. So winner, winner, chicken dinner is going to give us B. If the number in the front, the x squared, was positive, positive things are happy things, so we get a happy face. Just in case. Okay, let's move forward. Number 9. It is not a calculus problem. I apologize. It is an algebra problem. And it is going to be middle or high school. And let's go ahead. It is a word problem, but we're not scared of them because we know that they didn't do anything to us. It tells us that Dean earns $16 an hour for the first 8 hours of a workday. Okay. For each additional hour he works beyond the 8 hours, he earns time and a half. If Dean earned $320 for a single shift, they want to know how many hours did he work for that shift. Okay, so we can make a little equation for this and figure it out. We're moving that way, or we can just figure it out piece by piece. So I already know that he's making $16 for the first 8 hours. $16 for the first 8 hours. So for every hour, he's making $16 for 8 hours. What else do I know? I know that he gets time and a half for any additional hours. Well, what is time and a half? Time and a half is what he makes, the time, 16 per hour, and half of that. So 16 plus 8. So for time and a half, he's making $24 an hour. What do we need to know? We need to know how many total hours he worked based on him earning $320. So if his outcome was $320, what made the outcome? The outcome was made from his $16 multiplied by his 8 hours that he normally works, plus $24 times we don't know how many additional hours he worked. Remember, and this is the original hours. Now we got to do some math. 16 times 8 is 128, plus 24x is equal to 320. Right, we're going to subtract 128 on both sides. I'm going to write over here off to the side. 320 minus 128 is going to give us a lovely number of 192. And that is all equal to 24x. All right, last step, divide both sides by 24. And x is equal to what? 8. Well, what does 8 represent? Is that my answer? Are we winner, winner, chicken dinner right now? No, we are not. We are at the additional hours that were worked. So what do we now need to do? We need to take the additional hours, add it to the original hours, and we will have the total amount of hours that he did in his workday. So 8 hours for the original day, plus the 8 hours for additional hours, is equal to a total of 16 hours. Winner, winner, chicken dinner at C for 16. Yes, they like to throw number 8 at you and tell you that you've got to be done if you see a number that you've solved for, but that's not how it works. You always have to ask yourself, what did I solve for? Okay, my last question for the evening. Number 10. Number 10 is a number sense problem, which is elementary / middle. So we have to place the numbers in ascending order. Well, what do they mean by ascending? Ascending means from the smallest to the largest. Okay, well that can't be that bad. I'm looking at all my answer choices. I've got to figure out which one it's going to be. So all I'm going to do is take all of my numbers, put them all in the same form, and then figure out where to go from there. Well, I don't really know what to do, so I'm going to just try to turn everything into a whole number or a decimal and figure it out. I know that 33% sounds like money, cents. So I'm going to divide by 100, move my decimal 2 places, or think of 33 cents. Those are the 3 ways I'm going to do this one. So I'm going to get 0.33. No matter which way I look at it, I get 0.33. I'm going to put my calculator and use the square root of 64, or I ask myself, what number times itself will give me 64? Just so happens that 8 is the lovely winner on this one. So 8 times 8 is 64. The square root of 64 is going to give me a whole number of 8. And then I'm going to look at my 7 and say, okay, it's 7. But this guy right here, that guy's my kicker. What do I do when I have a negative exponent? Well, it means that you take your number and put it in the denominator. But if it's in the denominator, you take your number and you put it in the numerator. So you're taking the reciprocal of the number that you see. So now we have 1 over 2 to the 3rd power. Okay, we have a little bit more to go off of. Now we do 2 to the 3rd power, 2 cubed, which is going to give us 2 times 2 is 4 times 2 is 8. 1 over 8, And I said we're going to put it in decimal form or a whole number, so let's change that over into 0.125. Okay, so now I have 3 numbers that I can compare and actually figure some stuff out with. So my first number just so happens to be the last one that we solved. So I'm going to lead with 2 to the negative third power. Well, the next number is going to be 33%. Then I'm going to have 7, and then the square root of 64. So I'm looking for a number, an answer choice that gives me these numbers in exact order, and it happens to be B. Not that bad, right? If it had asked us for the opposite, for descending order, we would start from the largest and work our way backwards to the smallest, right? So it's just what they're asking for. The best thing to do in this case is always to change it into a form that makes sense to you. If you're staring at numbers and they're all different, you're never going to be able to figure it out if you don't just put them all in some kind of commonality, right? So that's it. The torture is over. Couldn't have been that bad. I haven't lost that much hair, which means you probably haven't either. But I want to say a big thank you to all of you for showing up today. And remember, the Learning Liaison does offer one-to-one extra help, which is our online tutoring service. You can always use Sync35 for a discount, right? And I am always here to help. Check me out for the one-on-one tutoring. I will hope to see you guys next week, and keep those smiles on. See you later.